Today I want to show you how we can solve some direct variation word problems. So the amount of money raised at a school fundraiser is directly, so we want to make sure we highlight the word directly, proportional to the number of people who attend. If the amount of money raised for 100 attendees was $35.50, how much money will be raised if 850 people attend this year? And how many people need to attend if the school needs to raise $20,000? So there are two variables that we are given here, money and people. So I'm going to say let M be amount of money raised and P be the number attending. Now we're told that the amount of money raised, M, is directly proportional, so we can say it's equal to K P, which is the number of people attending. We need to solve for K. So in these problems, they'll usually give the two variables so that you can solve for K. So in the first part of the question, they say the amount of money raised was $3,550. We don't have K, but we're told that we had 100 attendees when they raised $3,550. So your P is 100. Now we divide both sides by 100, so we get K equals 3,550 divided by 100 will give you 35.5. Now we can plug this 35.5 back into your original equation. M equals, now your K is now 35.5. We have our P. So how much money will be raised if 850 people attend? So 850, so our P now becomes 850. Our K is a constant, so that doesn't change. And we need to find our new M. So we're going to do 35.5 times 850. And that gives me $30,175. How many people need to attend if the school needs to raise $20,000? We write our equation. We already found K, so we don't need to worry about K anymore. So we can just write it as M equals 35.5P. Now they need to raise $20,000, so our M now becomes $20,000 equals 5.5. We're going to divide both sides by 35.5, so our P equals 20,000 divided by 35.5. That gives me 563.38. Now remember, we're referring to people. So in order for us to raise at least 20,000, we need to have our P 564, because even though we have a number of 563.38 and 3 is less than 5 behind our decimal, we have to round up, because if we round down, we will not make enough money to meet our $20,000 point. Here's another example. The amount of money Jim earns varies directly to the number of hours he works. He earns $56 for a 6-hour shift. Find the constant K and find the amount of money he will earn for an 11-hour shift. So we have two variables, the money and the number of hours worked. So let M be the money earned and H be the number of hours he worked. We are told that M varies directly to the number of hours he works. So we can say M equals K H, which is the number of hours he worked. If he earns $56 in a 6-hour shift, we can say that M is now 56 and H is now 6. We need to find out K. Remember, usually in the earlier part of the question, they will give you your constants for the two variables so that you can find K. And if we divide both sides by 6, we'll find that K equals 9 1/3. We need to find our constant K, so that's what we've found, is 9 1/3. Next, we need to find the amount of money he will earn for an 11-hour shift. So we go back to our M equals, now our K is now 9 1/3 times H. We don't know how much money he's going to earn, but we're given the number of hours he works, so we can say M equals 9 1/3 times his 11-hour shift. So your H now becomes 11. So we do 9 1/3 times 11, which comes to 102.6666. And I'm going to round it to dollars and cents, so I get 1067. And that's the amount he earns in an 11-hour shift. Here's another one. The cost of a pizza varies directly as the square of its radius. Note that it says square of radius. If a pizza with a 12-inch diameter costs $9, how much should a pizza with an 11-inch radius cost? Now note here that we're talking about different specifications. In this instance here, we're given the diameter, but we're talking about a variation that involves radius. First things first, let's specify our variables. Here we're given the cost and the radius. So let the cost of pizza be C and the radius be R. The cost varies directly. We can say that C equals, it's a direct variation, so we can say that's K R, but it's the square of the radius, so KR squared. Now we're also given information for a 12-inch diameter, but we're working in radius, so we're going to half that to say it's a 6-inch radius. So now we can say that your cost, which is now 9K, and your R is not 12, your R is 6. Now 6 squared is 36, so we're going to divide both sides by 36. And we get K equals 9 over 36, which equals 1 over 4. Now that we've found our K, we can plug it back to the equation we set up and answer the question, how much should a pizza cost with an 11-inch radius? So our cost is what we want to find, so we can say that C equals, your K is now 1 over 4, and your R is now 11. That gives me 121 over 4, which gives me $30.25. This question looks very different from the previous example, but it's actually very similar. The distance required to stop a car varies directly the square of its speed. If 200 feet are required to stop a car traveling at 50 miles per hour, how far after hitting the brakes does a car traveling at 80 miles per hour cover before it stops? And will it crash into the car in front of it if the car in front is 300 feet ahead? So we always want to define our variable. We're going to let the distance be called D and the speed be called S. And we're going to write it as D equals, because it varies directly, we say D equals K of S squared. Distance varies directly with its speed. Okay, so it says 200 feet is required. The K is what we want to find. And our S, which is the speed, is 50 squared is 2500. So we're going to divide both sides by 2500 and K. K, and cancel these zeros away, and that will give us 2 over 25. So we found our K, and then we're going to plug our K back into our equation that we set up in the beginning. And we want to find the distance, so we don't know what D is. So we can say that D equals, now your K is now 2 over 25. It's a nice fraction, so you're just going to leave it as fractions when we're working on this. And our new speed is 85. Square it, and that gives me 578. These word problems are nice because you can kind of use your common sense to check your work. So if it takes 200 feet to stop a car 50 miles an hour, we can kind of figure that a car traveling at a faster speed will take a longer distance. In this case, we compare it to 200 and 578. So yes, that makes sense that it takes a longer distance to stop for a car traveling at a faster speed. Now, will it crash into the car in front of it if the car is 300 feet ahead? Yes, it is going to crash because it takes a much longer distance than that 300 feet for the car traveling at 85 miles an hour to stop. In fact, it will probably crash quite hard. Be sure to like and subscribe to my channel. If you have any questions or comments, leave them down below. I offer lessons, notes, worksheets with full answer keys, as well as online tutoring services. Links below. Thank you for joining me, and I hope you found this lesson helpful.